Hello, today we're going to be working on the beginnings of probability, and we're going to be working in Text and Test 4. So we're going to be working in Text and Test 4 for the next little while, and we're on page 180 of Text and Test 4. So we've switched books to Text and Test 4. And what we're going to be looking at in the beginning is permutations, how many ways we can organize different events. And we're going to be working with the fundamental principle of counting, which you may remember are from junior cert probability, which just says that if we have several different options combined, we can multiply the options to find our total number of possible outcomes. We're going to look at that in practice now. We're going to start with question 3. A code consists of a letter of the alphabet followed by 2 digits from 1 to 9, e.g. A34. How many different codes are possible if a digit cannot be repeated in the same code? So we have 3 digits, and as we're going to do pretty much always for permutations, we're going to start out by drawing boxes. So I have 3 digits, and I'm going to draw a box for each digit. So this is first digit, second digit, third digit. Now the first digit, I'm looking at a letter of the alphabet. So how many options do I have for that? I have 26 options, 26 letters in the alphabet, so I have 26 options for my first digit. Now the second and third digits are numbers from 1 to 9. So how many options do I have for my second digit? I have 9 options. Now be careful with these types of probability questions. They could have said digits from 0 to 9, which would give you 10 options. So that type of thing often catches students out in exam questions. So from 1 to 9 we have 9 possible digits. If we were told 0 to 9, we would have 10 possible digits. Now, in this situation we have 1 to 9, so we have 9 possible outcomes for the second digit. But we don't have 9 options here. And the reason is we're told in the question that we can't repeat digits in the same code. So if we've picked one of our numbers here, it means we can't use it again here, so we only have 8 options left. So we have 26 options for our letters, we have 1 to 9 as our options for the second digit, and then for the third digit we've used up one of our numbers, so we only have 8 options left. Now, we can use the fundamental principle of counting now to find out how many possible 3-digit codes we've got. So we have 26 possibilities here, multiplied by 9 possible outcomes for our second digit and 8 possible outcomes for our third digit. And we put that into our calculator, we get 1872. So we have that many different ways of constructing our 3-digit code. So when we're doing this, we're going to draw boxes, use the story they've given us to figure out how to fill in our boxes, and then multiply out all of our possible situations to find the total number of ways that we can do something. To give you another example of that, where we start to introduce a few restrictions, we're looking at question 7 further down the page. And question 7 does something that a lot of probability questions have a tendency to do. It has a part 1 that isn't marked as part 1 of the question. In how many ways can the letters A, B, C, D, and E be arranged in a row? That's part 1 of the question, but it's not marked as part 1. So be careful of that. Now, we're going to answer that before we go into the rest of the question. So we are asked about the letters A, B, C, D, and E. So we have 5 letters in total that we are arranging. So I'm going to draw 5 boxes. 1, 2, 3, 4, 5. Now, I have 5 letters available to me for the first letter that I pick. So imagine I have these on a piece of paper pieces of paper in front of me on the desk, and I want to pick up my first letter. I'm going to have 5 pieces of paper that I could pick from. I could pick any letter from A, B, C, D, or E. And how many ways could they be arranged in a row means that when I've picked one of the letters, it's going to stay as my first letter. So Now if I'm picking my second letter, I'm going to have 4 options left, and then 3, and then 2, and then 1. So the way that I can write that out is 5 by 4 by 3 by 2 by 1. Now because multiplying numbers down like this, 5 by 4 by 3 by 2 by 1, is something we have to do quite a lot in probability, mathematicians came up with a special notation for it. So that would be called 5 factorial. So the normal exclamation mark that you're used to from English. And this is a button on your calculator, which on most calculators will look like X exclamation mark. And it's often a second function button. On Casio's, it's second function and then x to the power of -1 button. And that's going to give you your x factorial. So if you put that into your calculator in either form, you're going to find that you get 120 possible ways of arranging our 5 letters on a table. Now, let's get on to part 1 of the question. So we have part 1. In how many of these arrangements is D always first? So I'm still dealing with 5 objects, still dealing with my 5 letters. So I draw out my 5 boxes. Now I'm going to deal with my restriction first. So what's my restriction? I'm told that D is always first. That means that my first letter must be D. I only have one thing I can pick for my first box. I only have one option. It must be the letter D. After that, I have 4 letters left, and I can pick any of them for my second letter. So I have 4, and then 3 letters left, and 2 letters left, and then my last, I only have one option. So this is going to be 1 by 4 by 3 by 2 by 1, which you could write as 1 by 4 factorial, just to remind you of the notation. And when you put that into your calculator, you get 24. So there are 24 ways of arranging these letters when we have D as our first letter. And then part 2 of the question. In how many of these arrangements is A first and E last? So let's draw out our boxes. We still have 5 boxes. We're not told that we've removed any of the letters, so we still have 5 letters that we are dealing with. And we're going to deal with our restrictions first. So we're told that A must be first, so we only have one option there. And we're told that E must be last. So we only have one option there, because we only have one A and one E. Now we simply start filling these in once we've dealt with our restrictions. How many letters do we have left? We have 3 letters left at this point because we've used up A and D already. And then we have 2 letters left and 1 letter left. So writing this out, we'd have 1 by 3 by 2 by 1 by 1. And when you multiply that out, you get 6. So we have 6 possible ways of arranging these when we have A as our first letter and E as our last letter. Now a warning on language in these questions, because probabilities language is going to be our biggest challenge with it. The 2 ways of being asked about this type of question are permutations and arrangements. There are 2 names for it, and those are the 2 that you need to be aware of. If they are asking you about permutations of something or arrangements of something, how many ways can you arrange people or objects or just numbers, you're talking about permutations or arrangements, and you're going to be drawing your boxes pretty much every time you see the word arrangement or permutation. And you need to be careful. There's very similar type of questions that we're going to deal with the next day, which are combinations. But for right now, we're dealing with permutations or arrangements, and you need to be familiar with those words. Now, let's have a look at question 13. Same page, bottom of the page, question 13. In how many ways can 7 books be arranged on a shelf, taking 4 at a time? So we have 7 books, but we're only taking 4 of them. So we draw out 4 boxes. 1, 2, 3, 4. Now, how many options do we have for our first space on the shelf? We have 7 books that we can choose from. And then we'll have 6 books we can choose from, and 5 books we can choose from, and 4 books we can choose from. So that's how many options we have. We have 4 spaces on our shelf, and we have 7 books. So we have 7 books to choose from for the first space, 6 for the second, 5 for the third, and 4 for the fourth. And if we write that out, we have 7 by 6 by 5 by 4. Now this almost looks like 7 factorial, but we've gotten rid of 3 by 2 by 1. So I can put that into my calculator, and I'm going to work out that there are 840 ways of doing this, but I want to interrogate this a little bit further. It's like we had 7 factorial and we divided out 3 factorial. So if I write that out, I'd have 7 by 6 by 5 by 4 by 3 by 2 by 1. You can see why we use factorial notation. Divided by 3 by 2 by 1. Now you can see we can divide above and below by what is common, and we have 3 by 2 by 1 divides out, and we're left back with what we had from our picture. So our picture method gave us this answer, and now I'm trying to lead you towards a formula for this type of question. So we have 7 factorial divided by a 3 factorial. Now, what is happening in general is you can look at this as using a formula. It's called NPOR, which would be equal to n factorial all over n minus or factorial. Now I'm going to show you how this formula works in this specific example, but just to highlight that, n p or n is how you are going to see it on your calculator. So that's what the calculator button looks like for this function. So let's sub in here. N is going to be our number of books. It's the number of things in our original group, and OR is going to be the subgroups that we're taking. So in this case, OR is going to be 4. So we'd have 7p4 would be 7 factorial all over 7 minus 4 factorial would be 7 factorial all over 3 factorial. And we're back to our question that we were looking at a moment ago. So you can use the box method to figure out questions like this. You must know the formula that I've written here, and you must know it as a button that you can put on your calculator. So the way that you'd fill this into your calculator is you'd write 7, second function, and get your p, and then 4. And that is going to give you the same answer. It should give you 840 for the number of ways we can arrange 7 objects taking groups of 4. So arranging 7 objects taking groups of 4 of them. If we put that into our calculator, you're going to get that it is 840, just like we did above. So you need to know the picture method, you need to know the formula, and you need to know that you can put it into your calculator as well. You need to know all 3 methods, particularly this formula we are going to build on in the next section, and you must have it clear in your head.